5, 6 years ago, we had a student who was very interested in lighting. She had headaches when she studied under fluorescent lighting, which is what we have inside these buildings here. And so she wanted to see if there was a better way of doing that. We got to looking at some of the minerals that we had here at the college and exciting them with a blue laser pointer. And one in particular shone very, very brightly.
I came on to continue research done by Sarah Friedenson a few years ago, and I was just sort of learning about what we were doing and how to use the equipment and just the basics of lighting and how physics plays into it. So the experimental side of my research, both last summer and this summer, was focused on using the laser to excite the minerals and see what wavelengths were emitted and see what light we're getting out of it. From there, we use the theory to determine why it does what it does and to see at its most general physical properties, why does it behave the way it behaves and how can we mimic that in trying to create a synthetic mineral to use in lighting.
The LED that Nancy and Sarah have used in their research is one that is around 405 nanometers. It is a violet LED. And using that violet or even one more that's further in the ultraviolet, we can then produce light that is broadband, yellow, warm, just like the sun.
When you look at the theory behind the mineral, you see different things playing into it. There's different crystal structures because a natural mineral is going to have several different things in it. You have to see how much of the impurity, which is the sulfur that's not actually in the chemical formula for the mineral, but the sulfur in the crystal structure is what causes the fluorescence, and we call that an impurity. So we have to see exactly how that behaves in response to the rest of what's in the mineral and in the crystal structure so that we can mimic it correctly.
It's a long process. This has been going on for 4 or 5 years. And we are now to the point where we're ready to publish the results. We understand the system. We, from a theoretical standpoint as well as an experimental standpoint, and perhaps we will be able to contribute to the revolution that's going on now in lighting.